In today's lesson, we'll evaluate the integral of the square root of x² minus 1 over x using substitution. We'll specifically use a trigonometric substitution. Here's our integral to solve. Integral of the square root of x² minus 1 over x dx. Now, when we see the expression x² minus 1 within a square root, it suggests a trigonometric substitution. Specifically here, we can use the substitution x equals secant of theta. Now let's compute dx, which we'll need later. With our substitution, dx becomes secant theta tangent theta d theta, as the derivative of secant is secant theta tangent theta. Now we substitute back into our integral, which yields the integral of square root of x² minus 1 over x times secant theta tangent theta d theta. We can simplify this expression. Since cosine squared equals 1 minus sine squared, x² minus 1 becomes tangent squared of theta. The expression then simplifies to tangent theta. The integral of tangent squared theta secant theta can use the identity tangent squared theta equals secant squared theta minus 1. The integral simplifies to integral of secant cubed theta minus secant theta. In other words, we have integral of secant cubed theta minus integral of secant theta. The integral of secant cubed theta d theta by parts is beyond the scope of this video, so let's move on. Now we reverse substitute back into x, using our original substitution x equals secant theta. That gives us tangent of theta equals square root of x² minus 1. Therefore, integral of secant theta is equal to ln of secant theta plus tangent theta. Replacing these back in terms of x, we arrive at the result. Integral of the square root of x² minus 1 over x dx is equal to ln of x plus the square root of x² minus 1 plus a constant c. And this completes our substitution process. Thank you for joining for this substitution ascertainment.